Yowzers, lots of stuff going on. Let's blast through the bonus features segment. First thing, we're looking at our GPS errors. And we've got massive GPS errors here. A huge band of electrons. I believe Tamitha Skov may have forecasted this. GPS errors on the nighttime side of the planet, and there you can see them happening. Shout out to Tamitha, I believe it's pronounced. I'll let it play through a second time here. Yeah, Tamitha Skov. I think she forecasted these nighttime GPS errors here. Total electron content. It's the electron content from the plasmasphere and the inner Van Allen belt. Essentially, the whole space between your handset and your GPS satellite. This area right in here. We'll look at the ionosphere in a minute here. First, charging hazards. We ain't got none. We ain't got no charging hazards, see? There's a one-year chart on the electron flux. Pretty high levels here. We made it to about 8 times warning levels, I think it was yesterday. 9 times warning levels. So that's now subsided a bit, it looks like. A little lower levels than yesterday's midnight for the local time for the satellites, which is what those M's mean, by the way. That's midnight and noon local time for the GO 16 and 17. There's the forecast, expecting a dip, and I think there's a coronal hole wind stream or two on the way, so I would tend to expect that also. CMEs tend to cause a dip in the electron flux, or at least they're associated with dips in the electron flux. Next, the ionosphere, the F layer, which is, by the way, where the GO 16 and GO 17 measure the free electrons. They don't orbit at the F layer, they orbit at a geosynchronous altitude, similar to a GPS satellite, but they're using radiography to measure the ionosphere at about 300 kilometers of altitude. So anyway, there's the latest image. Here's the anomalygram. Keep in mind this is anomaly from the 30-day median. So we're showing sort of a long-term anomaly here. And you can change the settings on this if you want to go view it yourself. It's part of the Australian Government Bureau of Meteorology Space Weather Services. Anyway, there's the latest ionogram at 12:30 Universal Time. There's the latest anomalygram. A little low-frequency anomaly there over the African Rift Zone, near the south-central portion of the African continent. Anyway, welcome to the Neo Renaissance. Congratulations on realizing the channel exists. Please visit our links at smashamash.com. And perhaps consider becoming a member of the Smash team if you enjoy the content and would prefer the content remain publicly visible and free for all to view. Here comes some more classic bonus features. It's the ground-based solar observatory at Cerro Tololo, Chile. Yes, Cerro Tololo. There is a CME happening as we speak. Make sure you watch our previous video. We put 3 space weather videos out today. Our next bonus feature is the colorized magnetogram and solar intensity gram. So here's sunspot 2939 rather. Looks like it may have degraded a little bit here, still certainly capable of producing major flares. 2940, a ton of umbre there. Ton of umbre, capable of producing major flares. Here's a trailing spot. I'm not sure the number of that one, but this is 2936. And it has been certainly one of the largest sunspots of the entire solar cycle. Here are the fields. Flare probability remains high. There is still a forecast for additional CME strike. Maybe NOAA forecasted it as 2 pulses, I'm not sure. Or maybe it's just the trailing edge of a plasma cloud. In any case, got some additional bonus features for you here. The NASA GO 16 SUVI, always a classic with its wide field of view. It's great at showing prominences. And my coffee is prominently infused with cocoa and cayenne pepper, yes. Yowzers. So here's 304 angstroms. You're going to see a crazy plasma eruption coming out of sunspot 2936. And there is a CME unfolding as we speak. It's not earthly directed. Just another great light show and display of plasma accelerating out of the solar atmosphere. So here's another close-up of this. Yowzers. Great view of the flare there and the radio emission point, as well as a scale of planet Earth to give you an idea of the size of that plasma filament. Anyway, thanks for tuning in. May that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of a Smash News Network, least busted.